Hey everyone, Matt here from LimaCharlie. Welcome to the September 2023 Loud and Clear series. First off, this is the very first time we've run a webinar with our brand new website, brand new branding, brand new colors and everything. Hopefully you can see to the side of me just how great things look. In case you are unfamiliar with LimaCharlie, I highly recommend you hop over to limacharlie.io, check out the platform. Today's webinar is going to focus on a particular part of the platform, but I always want to take a moment and introduce the brand new scheme and brand new look we've got. Feels very refreshed. And if you joined us in July 2023 to learn all about the SecOps Cloud platform, we're glad to have you here with us today. So the Loud and Clear series is a little bit of a revamp of what used to be our threat detection workshops. Now, these are webinars that offer kind of pinpoint views on very unique features inside of LimaCharlie, how to use them, how to craft them, how to put them together, and things like that. The goal of today's series is to talk about scheduled event detections. There's actually a really cool feature inside of the platform that lets you turn LimaCharlie kind of into like your own little organization-based cron job manager, because you can schedule the platform to do things either against the organization or against sensors. And it's a really great way to automate some operations. And we'll walk through a few different use cases as well as how to bring them together. But before we do, a little bit of housekeeping. First and foremost, as I mentioned earlier, this is a brand new series. It is a revamp of our previous webinar series. We will be delivering our Loud and Clear video series on a monthly basis. So keep an eye in the Slack channels. If you're not in there, slack.limacharlie.io is where you can jump in and join our community Slack, totally free, and you can get insight into different announcements, blog posts, releases, integrations, all sorts of things that we're going to be doing, all available inside of Slack. I highly recommend if you're a LimaCharlie user, you might want to be a user, you're interested in the platform, or just want to catch up with some folks, highly recommend jumping into the Slack. It's a great place. Just an FYI for everyone here, if you've ever heard of the Cyber Defenders podcast series, the Intel channel is in our community Slack, which is where we pull from for our content there. Last but not least, we also have a brand new channel in the Slack called Loud and Clear, #Loud and Clear. That's going to be where we're going to keep discussion for these video series so that we can talk about these things in the future going forward and reference those examples. And if there's something we need to fix, edit, or change, it's a great place to capture those too. So if you're watching this and you're in our community Slack, please join the Loud and Clear channel. We'd love to have you in there. With that said, let's go ahead and get started. We're going to start by hopping into the LimaCharlie platform and take a look first at some of the different types of scheduled events. I'm actually going to start this in our documentation first before we jump into the platform. One of the first concepts I want everyone to be familiar with is the idea of different events that happen inside of an organization that are generated by different things inside of the organization. So one of the easiest ways to think of events are from a source of telemetry. So for example, if I have an EDR sensor deployed, that EDR sensor is going to generate system events, process starts, memory mapping, code identity, network connections, so on and so forth. If I'm ingesting Windows event logs, that may be another source of events. I also have the ability to pull from additional sources. So these are our LimaCharlie adapters. So if I'm pulling in AWS logs or Google Cloud Platform logs, whatever it might be, everything that comes in is going to be an event. Events are observable from our detection and response engine. Those of you who are familiar with LimaCharlie know any event that comes in is something I can write a detection and response rule against. Well, it's important to know there's also other events that happen in the background as well that you also can observe and write detection and response rules against. This is actually a really cool feature because it allows you to look at and think about your data in a different way. And I've started here in our documentation where we go through and identify kind of what it means to be an event inside of LimaCharlie. And you may notice that events are generated not only by sensors, adapters, but also generated by systems and services running in the background. There are events generated for when you pull artifacts from a system. There's other functions of the platform, such as when sensors are deployed. But the key thing for everyone to get familiar with for today's webinar is going to be, I can action on things other than just the system telemetry that comes in. So I have the ability to action on when an artifact is pulled. I have the ability to action on when a console command is issued. And the nice thing about it is that gives me a lot of flexibility to say, not only do I want to know when something happens, but I also want to do something with the output of when that something happens. So think, for example, if I was sitting inside of a console and in that console, I started to pull back OS packages, which, by the way, I'll hop over and show everyone, is a console command that works inside of Windows and Chrome currently and allows you to pull back the different types of packages that are installed on a particular system. So let's hop over here into some of our other capabilities, and I'm going to jump into our, I'm going to jump into our sensor commands, and we're going to take a look at things like the operating system. And here's a perfect example: OS packages. This is a command that lets you list installed software packages across Windows and Chrome currently. That's the way it's set up. There's some other operating system based events as well, such as pulling listing drivers from Windows or listing services from Windows, Linux, and Mac. The point being, there are additional types of data pulls that I can have the platform do. That is also an event that I can observe and I can respond on top of. So for example, I might run an OS services event that pulls all the services from my Windows systems. Well, I might then go a step further and say, well, wait a second, the response from that event, I can do something with that response. I can ship it off to an additional data store. I can ship it to a visualization platform, and I can model data around it. What we're trying to do is really flex on the idea of how can I look at and observe my data in a different manner. I'll tell you the old way of doing it. The old way of doing it was I would run a query that would pull a bunch of Windows event logs back. For example, if we're keeping the magnifying glass on Windows, I would run a query that would pull back a bunch of Windows event logs. I would then categorize, normalize, and slice and dice through those different entries. And I would have a point in time description. I would have a point in time view of services that had been installed across my Windows environment. This works for that one particular point in time. But let's say I wanted to run that weekly or daily, or I wanted to run that every month. Notice that we're moving away from reactive into proactive now. So when I think of a very basic bare bones threat hunting program, I think about starting with a query, finding value in that query, and then turning that query into a repetitive thing. So for example, again, I want to profile services. Services are a persistence mechanism that adversaries can use and a really good thing to look through from a threat hunting perspective. There's a lot of detections written around service creation as well. If you think about open rule sets like Sigma, Snap Attack, SOC Prime, all things that integrate with LimaCharlie, a lot of them will pivot on top of 7045 events. The tough part about that is, again, it's a point in time pull. Pulling all of my Windows event logs and profiling for a certain event ID is a point in time, and there's additional analysis that I, the analyst, or someone else has to do. So we gave a shorthand version of that by running OS_services. Allows you to pull back all the services from a Windows system, for example, and then do what you want with that data. By making it an observable event, it's not just a console output. It's also an event that I can see and observe inside of my timeline. Now, there's an important consideration here for everyone to know before you go through and start to quickly run all these events and not seeing what you're looking for. First and foremost, understand that inside of LimaCharlie, we have this idea, this concept of exfil control. It used to be exfil control. It's also now known as event collection. And this is where you determine and decide the types of events that you can see and observe in your environment. I'm here in a test environment that I've got set up, and I will show you event collection is where you determine the events that come from sensors to the cloud in real time. This is where we start. We start here because I want to make sure the data that I'm going to model against is present in my rules or present in my configuration. So if I pull up my Windows one, you'll notice that this OS services rep event, which I'm going to try and highlight, but I'm having my mouse hover over right now. It's about halfway down over to the left side. OS services rep is the response event from OS services. Let's hop into our console and I'll show you a little bit about kind of what this looks like. So I've got a test Ubuntu system here. We know that this particular command works for Linux. So I'll go ahead and type in OS services. We'll run that. And I get this nice little output back of all the different things that are running inside of this or on this particular system. If If I hop back over to my sensor timeline, I should hopefully, because it was inside of my events, let's go double check really quick and make sure that for Linux, we are collecting that. There's my OS services rep. We do see that in there. If I hop back to my sensor, here's my sensor in general. And I'm going to let my telemetry update really quick to see if I have an OS services rep command in there so that I can use that again to kind of pull that data and pull it back and then analyze a little bit further. So a key difference here, and my browser is not refreshing as quickly as I want it to. But that being said, I can hop over to the console and I can run OS services and I can look at this output here. I can also go into my timeline and look for that output inside of my timeline because it is, as I mentioned, an observable event. That's what I mean, first off, by understanding the different events that LimaCharlie allows you to look at or observe. This becomes very important as we get into schedule detection and response rules, because the idea of pulling back operating system specific information or consolidated information is something that I'm going to want to do repetitively. I am going to want to run something repetitively. I'm going to want to analyze it repetitively, but I'm also going to want to do this thing at scale. I am not going to want to have my analysts log into every single system, every single time, hit the console, dump back a particular request, take that, output it to a CSV or a JSON or whatever it might be, and repeat this process for every single system that we've got deployed. It's just not going to scale. It's not going to work out. So there's multiple ways to, of course, go about satisfying that. The first is I could go and write a script, and that script is going to let me automate through all of my different sensors, and I can issue commands. And because LimaCharlie is an API first platform, it's really straightforward to just go and pull all that data down. Well, we found a way to make that problem actually go away. We found a way to make that easier for you. And the way that we go about doing that is we created these things called scheduled events. Now that we understand the concept of events, and we know that there are events outside of system telemetry or adapter telemetry, we now understand that there is a concept in the back end of LimaCharlie called schedule. Schedule is where you have the ability to tell the platform, hey, I would like to schedule something to happen every interval, whatever that interval might be. And we'll talk about that frequency in just a moment here. But it then becomes another observable event. It actually becomes a stream that you can observe and target so that you can write detection and response rules. So let's go back to my earlier case study that we walked through just a moment ago. Let's say I wanted to pull services from every Linux system or every Windows system or every system in my environment. Rather than have my analysts go through and hit these one by one, and rather than try to write a script to make that thing work as well, I could instead tell the platform, hey, I would like you to pull services from my environment every 30 minutes, every 24 hours, whatever the interval might be. And sure enough, just as I mentioned, here's our OS services rep event, OS services, OS underscore services underscore rep event. This is the observable event from me issuing that OS services command. I told you it'd show up. I just had to click around really quickly there. But because this is an observable event, I can not only automate the issuing of that command, I can then do things against that response when it comes back. All right, let's get back to scheduling and talk a little bit about how we make this frequency show up and how we put it into play. First and foremost, frequency is the most important thing to understand, as well as the diversity of the schedule target. So first off, the frequency we want to declare is really what it is you're trying to pull. And I would encourage you, if you're going to use the schedule target, if you're going to utilize this feature or functionality, think about what it is that you're pulling and how often you want to pull back that data. So again, my use case of pulling services from Linux systems, services don't really change that much to the point where I need a lot of volatility. At least they shouldn't be changing that much. So that might be something that I might pull on a 24-hour basis. Again, depending on the type of analytics that I'm trying to do after the fact. However, I would go a step further and I would argue that if I'm in an active IR or I've got an active adversary inside of the environment and they're going through and making changes, I might change that frequency to every 30 minutes because I'm looking for those upticks and changes. I'm looking for those things to happen. The other thing to be aware of is what I can pull and where I'm going to be putting that data. So we talked about frequency. We also talked, or the other thing that we should explore is where I'm going to issue that particular command. So there's 3 categories of where the schedule target can be applied. The first is per organization, or underscore per underscore org. These are events that are emitted once per period per organization. So for example, if I say once every hour inside of an organization, then it's going to be once every hour, similar to a cron job. This allows you to schedule things at a global level if you need to. Perhaps the one that everyone's a little more interested in is going to be the per sensor. This is where events are emitted once per period per sensor. So per period might mean once every hour, once every 30 minutes, once a week, whatever it might be. This is how you're going to schedule automation for every sensor inside of an organization. The other feature that we've added on is also per cloud adapter. These are events that are emitted once per period per cloud adapter, regardless of what that adapter might be. So for example, you might have adapters that connect to AWS, adapters that connect to Azure, adapters that connect to GCP, to 1Password, to Slack, whatever it might be. And in this case, you're going to say, every hour, I want to pull that resource for a thing. Or every day, I want to pull that resource to make sure it's online. The other important feature here, and you'll notice it in some of the output, is that the per sensor and the per cloud adapter also include a runtime metadata component as part of them. And I'll highlight it right here for you. This is on the sensor side. This is some metadata about the runtime for that particular instance. Here it is for sensors, and here it is for cloud adapters as well. And this can be really, really useful to actually pivot against the metadata to look for things like host names or adapter types and to profile those out. So one thing that I might do is I might, per cloud adapter, every day run a poll that pulls back the metadata about them and then use those to categorize where I'm seeing the most activity or what types of adapters I have running, I have live. This is very useful because it takes you out of having to kind of scroll through the sensor list or perhaps use the API call to once a day pull those down. You can instead have those events generated for you. Now, really quick, let's talk about that workflow and how schedule events can change a couple of workflows before we get into writing our first rule. So first and foremost, as I mentioned, these are all observable events within the platform. So just like I mentioned earlier, the OS underscore services underscore rep event is the response event for me writing or issuing the OS services command. We already know that I have the ability to automate the pulling of that command, but once it's automated, what do? You do not have to come to the timeline for every system and look for those events. Because the OS underscore services underscore rep event is observable inside of the detection and response engine, it's also observable in the output side of things. So follow me down this train. I'm going to use some sort of an automated approach to run OS services on all of my Linux systems once a day. I'm going to want to push that data out to some sort of a platform for a visualization or a data consolidation or a threat hunting perspective. So we'll hop over into outputs, and I'm going to create a really, really simple output based on certain events. And just for, let's see, I'm going to make it pretty straightforward, and we're just going to configure this for, of course, there's certain things that we can and can't do, but let's just push this out to an Amazon S3. Ignoring the configuration details for now, because we're not actually going to create this adapter. What I'm more interested in is that particular event that I can use, that OS services rep event. So what I've done now is I've told or created an output, and I've told the LimaCharlie platform, I want you to take this one particular event, this only thing that's out there, and push it to a particular S3 bucket. What I'm going to end up with is once a day, when my scheduled job runs, that S3 bucket's going to have a new series of events in it that I can pull from and do additional analysis on if need be. Of course, there's other options inside of LimaCharlie, but I'll talk about those in a second. But let's go back and take a look at what that detection and response rule looks like so we can break this workflow out a little bit further. We do have a sample rule written in here that works per sensors. It's actually very similar to what we've talked about before from a services perspective, but it focuses on the packages side of things. But that's not what we're going to look at. We want to stick with our use case here. Remember, just to keep everyone fresh, our use case is dumping services from Linux systems once a day. Let's write that detection and response rule. I'm going to grab our sample from right here. We're going to go ahead and copy and paste that. And I'm going to head over into our detections area for our test organization here. From our documentation, I'm just going to go ahead and drop this in. We've got this, the rule was written in one piece, or was written as one code block inside of our documentation, but let's break it out for our scheduled events. So on the detection side of things, I'm going to get rid of our response and just throw it down here. On the detection side of things, let's walk through each one of these parts. All right. And I'm going to zoom in on this a little bit so we can see. Oh, I was hoping I was going to zoom in. Let's zoom in that way. There we go. So first and foremost, we're understanding that we are not targeting, in this case, the EDR sensors or the adapter telemetry that comes in. The target is the most important declaration because it tells the platform, I want you to look over here instead of over there. So our target in this case is going to be schedule. This tells the platform in the form of a detection and response rule, I am scheduling a thing. I want the scheduler to run something for me. The event is going to be how frequent you want this thing to run. If we head back to our documentation, notice that my frequency ranges from 30 minutes to 1 hour, 3 hours, 6 hours, 12 hours, 24 hours, or 168, which is a week in this case. So we can schedule everything at whatever intervals work for us, but there are some predefined quantities that are worth knowing. In this case, I said I want to know the number of services or the running services on Linux systems every day. So I'm going to set with a 24-hour per sensor period. Now, really quick, the reason I'm choosing the 24-hour per sensor period is because I want these commands to run on every sensor that I've got out there. I'm not looking to run these at that higher organization level, meaning I don't want this to run across every single adapter and every single system that's out there. I want to specify a group of sensors. We're going to do that with our per sensor declaration here. The next thing is to drop in a qualifier. This is where you make things a little bit easier. You help streamline your detection and response rule just a little bit. This is where I'm going to perhaps define what that program, that threat hunting program may look like. Again, if my goal here is to dig through persistence mechanisms that adversaries might use, then I'm going to drop in a quick operator that is platform that is going to help me determine and tell the system, I only want you to run these things against Linux systems. Now, of course, there's a multitude of ways we could put this together. We could utilize tags. We could drop in a series of just host names if we wanted to. We could do starts with, end with. We could do an IP range. The important thing here is that you've got the ability to customize and run these against whatever platform you want to run these against, or I should say whatever target you want to run these against. Where this becomes critical is how you're using and building with LimaCharlie. So for example, if I just want to run this against all my Linux systems, and my goal here is to just collect metadata that I can use for analysis later on or threat hunting later on, then a simple operation or a simple platform declaration should be enough, right? However, I might want to go another way, and I might want to say is tagged, and I'm going to call this high priority active IR. And what I'm going to do is, as I'm performing an IR, as I'm performing an incident response, and I've got systems of interest, I'm going to add this tag to those systems. And the nice thing is, with this rule in place, by hitting a tag, anytime a new sensor gets added to that tag list, it's going to be picked up on the next schedule run. This is another way to really easily automate things from a LimaCharlie perspective. Is again, if there's data that I want to pull on a consistent basis from my systems, and I use tags as my pivot, then the next time that operation kicks off, they get picked up from the tag perspective. And of course, it obviously would work from a platform perspective as well. However, tags give you a little bit more of a granularity control if need be. But in any event, I'm going to keep this one really straightforward, and I'm just going to say run this every 24 hours against Linux systems in the environment. Now, of course, the next step is going to be, what is it you'd like to do when this rule trips? Now, the one nice thing about LimaCharlie's detection and response capabilities is that you've got granularity over both sides of that equation. So I can get as granular as I want with the detection rule. I can also get as granular as I want with the response rule. And in this case, it's going to be pretty straightforward for us. I'm going to my action is going to be a task in this case. And I'm going to task OS services to run. You do have the option to specify an investigation if you'd like. This is just another little piece of metadata that gets added in that allows for some additional qualification on the data pool if you need to. I'm just going to call this the daily services Linux list. And in this case, it's a really straightforward name. This investigation is not a case. It's not any other sort of delineation. It's not a qualifier. It's just an extra piece of metadata that gets added to my output, so I can use it for filtering if I want a little bit later on. And I'll show you where you may want to use this differently is, let's say I was running this as part of a Q4 threat hunting program. Then in that case, pardon my typo, I could do something like this. And then when we get into Q1 next year, I could then come in and change my detection response rules. And what I'm going to get here is a bucket of information, and that investigation field can also become a qualifier for you there. But in that case, let's just keep this to daily Linux services. And in this case, all I'm doing is, again, pulling Linux services back and looking through that information. Now, a couple of things are going to happen here. First off, let's walk back through our documentation and take a look at the setup here. One thing to note or one thing to mention is there are some qualifiers for whether you run a rule against an organization or against a sensor. In this case right here, events that are run per sensor, which is what our detection and response rule is written against, will only hit sensors that have been online once in the last 30 days. So if you've got really, really old sensors lying around and stuff like that, they need to have been online in order to have been targeted by this. Of course, that makes sense, though. If a sensor is not checking in, we're not going to be able to pull information from it. Number two, scheduled events that we run are not retained as part of that yearly retention provided with LimaCharlie. What's interesting about this is that you do not get you do not get scheduled events observable and searchable from like the LimaCharlie query language and things like that. These are very, very short-lived ephemeral events, very short-lived. They are, of course, observable and actionable, so we can do things with them, but this is not something that you will be able to look back via LCQL and say, oh, show me all of the schedule hits over the past 30 days to see what's come up. So the reason I started this webinar off by talking about observable events and observable response events is in order for me to then capture this information and send it off somewhere else, I'm going to need to hit the event response itself, which of course we know in this case is OS_services_REP. That's how I target those particular events. Hopping back over to our detection and response rule. In this case, again, we've got our detection part set up. We've got our response action set up as well. I'm going to go ahead and save this rule. We're going to call this our daily Linux services pull. I'm not going to put an expiration on it. I'm just going to go ahead and hit save. And at this point, we now have a detection and response rule up and running that will hit Linux systems daily and pull back OS services. Let's see how quickly this thing ran if it actually kicked off soon or within my observation window right here, meaning within the time of this webcast. So notice, since we went and ran this thing, there's been a little bit of activity that's taken place. Things like processes and network connections and things like that. So that schedule target may take a minute to get up and running in the background, but we've now got a rule running that will go ahead and once a day or once every 24 hours, issue that OS services command to all of my Linux sensors and create that observable output, that observable event in the background. If I go ahead and navigate back to our timeline, we'll notice and see that our system is continuing to run. So let me pick on an older event to talk about how we might want to use this. Notice in this case, again, as I mentioned, we have that OS_services_rep event. These are the response events that will be emitted from that scheduled detection and response rule. So the easiest way for me to do something with this data, as I showed you a little bit earlier, is to write an output for it. In this case, we're going to, again, create an event output. We'll walk through the same example, piping it to an S3 bucket, and I'm going to select that particular event. There we go, my OS services rep. So hopefully this tied everything together. Let me walk one more time through the overall logic flow of what happened here. We started out by looking at observable events outside of normal system telemetry inside of LimaCharlie. Understanding that if I issue a command to a sensor, the response, that data response, is going to be something observable, means we can do something with that event. Creating an output allows you to take a response event and send it to a certain location. And then, of course, we go down the road of, well, Matt, what if I want to do this thing every n interval period? That's where we get into the schedule events capability within LimaCharlie. This is where I say, I want to pull this data once a day, every 30 minutes, once a week, whatever it might be. But the concept of observing that event and actioning against that event is the exact same. All I'm doing is utilizing the backend scheduler, or the internal cron job, as I've sometimes called it, to issue that command for me. But my actions on that event, my actions on observing that, are going to be the exact same, which means I am going to want to do something with that data afterwards. And just to kind of help drive this point home, here's actually an instance where processes were run. Notice that OS underscore processes rep is another event that's observable. And I'm trying to consolidate these a little bit while looking through them here. But here's another way that you could generate an automatic event, pull it back into some sort of an analytics platform, take a look at it, or work through it manually if you wanted to. Wouldn't recommend it, but you certainly could. However, this is another type of response event that you might want to automate in order to get insight into what's happening in your environment. Hopping through in my OS underscore services rep, we then have an observable event. And notice in my test Linux system here, I've got 27 events running. And in this case right here, I now can say, what type of analytics is it that I want to pull? Do I want to profile service names? Do I want to look for differences from day to day? I could utilize tables and different types of databases to compare from day to day and say, between yesterday and today, 2 new services got added. What were they? What do they mean? What types of names am I seeing? Do they have any indicators as to what they might be? Furthermore, we can also utilize the outputs options to push those into different locations. And this is where it can get a little more interesting if we want to. So again, let's say, for example, I am using these events to build some sort of threat hunting or proactive program. I'm profiling services to say, show me all of the different services that have come back. I am then going to specify a little bit further. And I'm going to say, let's pick in this case, and let's say I'm going to look for the Linux tag. So notice I talked about Linux tag being Linux being a platform. It can also be a tag that I utilize. Or perhaps I want to do something like active incident response as a tag. So what this is going to do is it's going to, first off, my scheduled cron job, which we wrote against all Linux systems in the environment, is going to hit every Linux system that's out there, or every Linux system in my organization, I should say. But perhaps I'm only interested in incident response right now. Well, the nice thing here is we could have put this tag declaration in the incident response, or in the detection and response rule. We can also put it at our output level. So that way, and this is the pretty cool part about it, that way, rather than limit the data pull from a detection and response perspective, I limit the output from an output perspective. Let's talk about why that makes it a really flexible option. That detection and response scheduled event is still going to run every 24 hours. It's still going to hit every Linux system inside of my organization. So that data is still going to be there. Not the scheduled event, but the OS services rep event is going to still be there. So if I need to go back and pull that data in a future period, I've still got it there. The output only uses a tag qualifier to send out. But if I need to go back and hunt through that data historically, it's there, and I certainly can. And I'll show you an example of kind of what this looks like here. Is take a look at and I'll pick on the OS processes rep event. So here's an example of our OS processes rep event that I searched for. I've run this command multiple times over the past few days. And interestingly, those response commands are still present in my history. Now, this isn't really crazy insight information because I don't have any active adversaries on the system, at least that I'm aware of. But take a look at how over time, the number of processes has fluctuated a little bit. 83, 85, 84, 86. It's just a number. It's an arbitrary integer at this point. But the important takeaway there is that I have this event observable through the history of this particular system. Let's say I was in an active incident response, but this system was not in scope. I would not want to have said, oh, I really wish I had that data from back then. So the workflow here is create a scheduled event and run it against an entire platform of systems. Run it against all Windows, all Linux, whatever it might be. Let that data live in your timeline. At the output, use your tagging to filter the output down. This is how over here at LimaCharlie, we really help with data consolidation and data usage, is we let you control and filter the data wherever you need to while hanging on to the original events for you. So now I can have an active incident response dashboard, and I can utilize tags to send whatever data I need to that incident response dashboard. And if any system comes into scope in the future, and it was not in scope at the time I created a particular event, guess what? The data is still there for me to reference. And I can go pull it, grab it, and ingest it into the database. So I've got that internal, or I should say I've got that visibility to previous events, even though at the time this thing ran, this system was not in scope. I hope that made sense to everyone, but there's quite a few ways that you can utilize the scheduled event or the event scheduler, the scheduled detection, to create really great detection and response rules. It also allows you to deal with multiple different use cases that, again, are really going to depend on what it is you need to achieve. Notice that when I talk a lot about detection and response rules, I talk about them from kind of a proactive or reactive stance, such as threat hunting programs or incident response programs. However, the other really useful use case, which is actually the one that we've called out here in our example, is simply just dumping packages from Windows systems. So the detection or the sample detection and response rule here runs once a week, and it pulls the list of packages from every Windows system inside of this organization and simply holds on to that event for you. This is very, very useful from a simple asset classification or asset inventory perspective. Now, of course, this is not going to be as granular as version numbers and every single linked file and DLL supports and things like that, but it is going to be a very useful way to say what's been installed on these systems and what's changed from week to week. So this is another way to really expand LimaCharlie's capabilities outside of that go find bad malicious activity and more into a IT operations capability. This is where I can use LimaCharlie to profile my environment and then start to work analytics on that particular profile. The first week, the data is going to be kind of what it is and what it shows you. But if I start to pull this data every week, 8, 9, 10 weeks in, I now have a running inventory of what's going on inside of my environment, and I can look for those different changes. What users have installed things, where have they created, have I seen recent package updates come out? Is there a browser update we need to perform? Or I'll use this from a vulnerability perspective. I will run packages once a week. And then when a vulnerability announcement comes out, look through those historical events to say, does anyone have this vulnerable browser or application installed? And is there an update we need to do somewhere? This is how we take all this observable data and build something additional with those capabilities. In any event, lots of capabilities here. I hope this was useful. Let me do one more kind of summary point just to bring everything home for everyone. And by the way, I hope that you've been active in the Loud and Clear channel. I'm going to be taking a look at that as soon as we end this webinar and to see what types of questions have come up. But let's summarize. So again, there are a bunch of different types of observable events inside of LimaCharlie. They range from your EDR system telemetry all the way to platform operations, response events, things that come back from users issuing commands. I should say LimaCharlie users issuing commands through the platform. One of the targets that you can schedule or you can write detection and response rules against is the schedule target. This will essentially create a cron job against an organization, against a sensor, or against cloud adapters that allow you to do a thing at a set frequency. Because the response from that command is observable, we can utilize detection and response rules to generate observable events that I can then do things with. The example we walked through was once a day pulling services installed on all of my Linux systems, outputting that data to a certain location, and then using that to generate future analytics. And I would say we've probably barely scratched the surface of the different use cases that these schedule events or these schedule capabilities can offer for you. So with that said, everyone, I'm all set with this one. Hopefully this was a good webinar. I enjoyed kind of walking through these different use cases. If the way that we approach these different events is something that you've seen very useful, let us know. We'd love to hear any feedback or insight or anything you might have. Again, check out the Loud and Clear channel in our community Slack. Would love to keep the conversation going there. I'll see you next time in October, where we'll do another Loud and Clear kind of hands-on webinar series. But in between now and then, catch you in the Slacks. And I'm hoping that we'll be able to have helped you generate some new ways of observing and actioning against your data. All right, I'll see you next time.